1.1a for Math 114. Oops, let me go back here. The language of the algebra. So we have our four basic operations: addition, subtraction, multiplication, and division. And we have a number of phrases that represent addition and subtraction, multiplication, and division. So a plus b, there's our notation, a plus b. You could also use the word sum. Sum is the answer to an addition problem, a plus b. Now, what you might want to do in your notes is put parentheses around the a and the b, because traditionally you will put parentheses around the sum. That's the answer. You have to do that first. A increased by b, b more than a. Notice the letters are switched. The word than means to switch the letters around in this order, a first, b second. The total of a and b, again, I would highlight total, put parentheses around a and b. You're asked to find this answer first. B added to a. Again, b is first, but we're going to add it to a, which means it comes after the a in notation. Subtraction, a minus b, that's our order. The difference, just like sum, it's the answer to a subtraction problem. Put parentheses around a and b. This answer should be parentheses a minus b. A decreased by b, b, there is that word than again, b less than a, you have to switch them around. A comes first, b is second. And of course, b subtracted from a, this one sounds better to put b after the a. A times b, that's ab. The product of a and b, again, product is the answer to multiplication, so a and b should be in parentheses. Twice a, sometimes you have a word that represents a numerical value, so twice is 2, then times it to a. A divided by b, there's our division symbol. The quotient of a and b, again, that's the answer to a division problem, so again, put parentheses around the a and the b. The ratio of a and b can be written as a fraction. Either of these two fractions work. And b divided into a gives us the long division box. All right, examples. We're going to write the following phrases as a math expression. The rate r multiplied by 5 is r times 5. All right, but to simplify our notation, we will have a tendency to put the 5 first, then the variable. The product of rate r and 9, r times 9, 9r. 8 less than, there's that word than. The product is the answer to a multiplication problem, so I put parentheses around it. And then the minus 8 comes last. Now, what is my product? It's the product of the distance d and 6, so d times 6. Well, using this notation up here, we'll rewrite it as 6d minus 8. Now, here we don't need parentheses around the 6d because multiplication comes before subtraction. We'll talk about orders of operation in just a minute. Next, completely simplify the expression. Now we're looking at combining like terms. We have variable terms and we have constants. So I start looking for a w, technically to the first power, looking for another w right there. Always include the sign in front of the term. Well, in front of 9w is a positive symbol that we don't need. So there is a sign out there. So 9w's minus 8w's, treat the w like an object, it's 1w. 13 minus the 5 gives us a positive 8, so w plus 8 is our answer. Here we have two different variable terms, u terms and x terms, and we have a constant. Again, start at the beginning, box off your 6u, find another u term. There is a positive 3u, 6u plus 3u is 9u. Next term is a positive 5x, find the next x term, positive 2x. 5x's plus 2x's is 7x, so plus 7x. Bring in your plus 4, there's your final answer. So combine like terms in this expression. Again, start with your a term first. Combine it with the 6a, that's 20a. 13 plus 27, that's a 40. 20a plus 40 is my final answer. Number 7, whoops, careful here. They give us a squared or a power of 2 on our z. So we have to have this z squared. They are alike. Now, if this was z to the first power or just z, or z to the third, you would not be able to combine them together. All right, so the variable has to be the same and the exponent on the variable has to be the same. Since these are the same, we'll combine them together as an object. 13z squareds plus 4z squareds is how many z squareds? 17z squareds. 2p minus 1p variable is a positive 1p. So again, here you don't need to keep the 1. You can just write it as 17z squared plus p. 8. Now here we have an expression, a sentence that turn into an algebra expression, and always identify the variable first. If we let W represent Milan's score, so then immediately go up to where it says Milan's score and put a W above it or below it. So this is going to be 2 times W. You have Rita's score is 11 more than, keyword than, 11 comes last. So plus 11, here's my blank. What's in my blank? More than 2 times W. Well, 2 times W is 2W plus 11. Ted's debt is going to be equal to, read the variable, Y represents Mike's debt, put a Y here, cross it out, put a W, below or above. 9 less than, so again, big blank minus 9. What goes in the blank? Half of W, that's a multiplication. 1/2 times Y. So you can write this as 1/2 times Y, or you can even put Y up in the numerator and call it Y over 2 minus 9. That would work as well. Number 10, 5 friends went to a basketball game. The admission price was X dollars per ticket. 2 of the friends also purchased t-shirts for $27. Write and simplify an expression for the total amount spent by the 5 friends. Well, all 5 people had to spend X dollars. So you can go X plus X plus X plus X plus X. But repeat addition of the same thing is defined as multiplication. So 5 times X. And 2 of those friends bought $27 t-shirts. So that's plus 2 times 27. This we can simplify to be 54. And 5 times X is 5X. So there's our variable expression. Now part B, it says, well, if the price of the ticket was $30, now we're going to substitute 30 in for X. So 5 times 30 is 150, plus the 54 for the t-shirts, that's $204. 11, a gift set of movies contains 3 action movies and 5 dramas. Let X represent the cost of each action movie and Y represents the cost of each drama movie. Okay, so 3 action movies, that's 3 times X. 5 dramas, and Y is the drama, that's 5 times Y. This is an entire gift set. All right, so 3X plus 5Y is my entire gift set. If you purchased 11 gift sets, this is why we want parentheses around it, because now we want to multiply 11 to that. And if you didn't put the parentheses there, we would make a mistake and multiply the 11 only to the 3X, but yet it has to be multiplied to both of these. There's 8 movies in a gift set. So 8 times 11, I have to write an expression that says 88 movies. So 11 times 3X and 11 times 5Y, 33 times X, 55 times Y, 33X, there's 33 action movies, plus 55 drama movies. How many movies totally do we have? We have 88 movies. Now I cannot write this as 88XY. I have to keep them separate. I want to know how many were action movies and how many were dramas. Number 12, exponential notation. Anytime you multiply something by itself repeatedly, we're going to shorten that up into exponential form. 5 times 5 times 5, there's 3 5s, that's 5 to the 3rd power. 5 times 5, 5 squared. 1, 2, 3, 4, 5 4s being multiplied together, 4 to the 5th. 1, 2, 3, 4, 5 threes, 3 to the fifth. 2 to the fifth, and you want to simplify this. That's going to be 2 times 2 times 2 times 2 times 2. That's 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 17, simplify the expression with exponents. So they want to leave exponents in this answer. So this is technically a negative 4 times a negative 4. Well, let's talk about negative numbers here real quick. A negative number is defined by the number 4 being multiplied by a negative 1. Now, these multiplications can be in any order because they're commutative. So negative 1 times a negative 1 is a positive 1. Well, multiplying anything by 1 doesn't change anything. So we're left with 4 times 4. So 4 times 4 is 4 squared. I simplified it with positive base. It simplified away the negatives. Now, if this was negative 4 raised to the third power, then 3 negatives multiplied together would be a negative 1. I would still keep the negative 4 to the third power, or I could write negative 4 and raise it to the third power without the parentheses. All right, so there's 1.1a.